The if elif else ladder. Speaking from the logical point of view, we have looked at examples in which there is a single if statement. We have looked at an example in which there is an if statement with an else clause. However, the most cases it caters for is two. That is, if this is true, do this, otherwise, do this. In the real world, however, there will be instances in which we have to cater for several scenarios. To allow for our program to be versatile and accommodate these scenarios, we would use a complex build-up of if and elif statements which will conclude with the else statement. This structure is called the if elif else ladder. The elif keyword is basically short for else if. In Python programming language, the keyword is elif. We will see how this works in Python. The main point to understand with the if elif else ladder is that each condition will be approached to be tested until a feedback is obtained or the end of the script has been reached. Let us view the syntax of the if elif else ladder in Python using a simple example. A common example, and the one we will look at, is a simple program that may be used to grade a student's mark accordingly. Mark is equal to int input. Please enter the student mark. If mark is greater than or equal to 90, print A plus. Elif mark is greater than or equal to 80, print A. Elif mark is greater than or equal to 70, print B. Elif mark is greater than or equal to 60, print C. Elif mark is greater than or equal to 50, print D. Elif mark is greater than or equal to 40, print E. Else print fail. Looking at our example on the previous slide, we are able to see, number one, we have requested the user for an integer input representing the student mark. Number two, we will store this input in a variable called mark. Next, we will see the if elif else ladder. Number three, we see several conditions that are placed in a hierarchical like structure, thereby representing a ladder like formation. Number four, for each condition that is being tested, if it is that particular condition that evaluates to Boolean true, then the code inside that condition will be executed. As you will also see, we have indented the code to be executed inside each condition if that particular condition gives us a Boolean true. As always, we shall analyze the program by executing it and providing input. Please enter the student mark 85. A. As one can see on the previous slide, I have ran the program and entered a value of 85. The program has returned a message which says A. This tells us that a mark of 85% will fall into the mark category of being an A. But why has our program returned A as the grade? Let us understand the logic that we have coded into our program. Upon running the script, compilation occurred and interpretation occurs line by line. First, I am prompted to enter a mark which represents a student's mark. I have entered a mark of 85 and thereafter pressed enter. When I pressed the enter button, the next piece of program logic was to conduct tests on that mark or value to see what category of grade it falls into. The first test was if mark is greater than or equal to 90. Our mark was 85, therefore mark is not greater than nor equal to 90. Hence this condition evaluated to false. Being false, the next condition in the ladder was approached, which is elif mark is greater than or equal to 80. This condition evaluated to true because 85 is greater than or equal to 80. Therefore, our program logic entered the code within this condition and executed it. This accounts for the A grade category that we are able to see on the screen. We shall test the program again but using a different value. I have used a student mark of 40. Please enter the student mark. 40. E. We observe that the grade our program has classified a mark of 40 as is an E. Let us see why. So we have ran the program, entered a mark of 40 and pressed enter. Now when we pressed enter, our program proceeded to conduct tests on the value we provided. The first test was if mark is greater than or equal to 90, this condition evaluated to false. 40 is not greater than nor is it equal to 90. The program logic then looked at the next condition. Elif mark is greater than or equal to 80. 40 is not greater than nor is it equal to 80. Therefore, this condition evaluated to false. The condition we approached was elif mark is greater than or equal to 70. Again, 40 is not greater than nor is it equal to 70. We have another boolean false. The next condition was elif mark is greater than or equal to 60. This condition evaluated to false because 40 is not greater than nor is it equal to 60. Next we encounter elif mark is greater than or equal to 50. This condition is also false because 40 is not greater than nor is it equal to 50. Hence we move on. The next condition is elif mark is greater than or equal to 40. During the execution of our script, this is the point in our program when the condition evaluated to a boolean true, because 40 is greater than or equal to 40. Therefore, with a boolean true being received, the program entered into this particular condition and executed the code within it. This accounts for the E grade that we see on the screen. To boost your understanding of the program logic and the way in which the if elif else ladder works, I shall provide a simple diagram. Number 1, program start. Number 2, capture user input. Number 3, condition false, move to next. Number 4, condition false, move to next. Number 5, condition false, move to next. Number 6, condition false, move to next. Number 7, condition false, move to next. Number 8, condition true. Execute code within and break out of if elif else structure. Number 9, default condition. If no conditions in the if and elif statements are true, the code inside here will be executed by default. Number 10, program end.